Oh, everybody kind of showed up at the same time there. That was cool.
Yeah.
Yeah, everybody.
How's it going?
Doing well.
Cool.
Joshy, I'm just reading your message in Discord related to Genesis hash.
Oh, yeah?
Yeah, I'm just thinking that in situation when we have a fork, right? In that situation, we have another information that we need to include, like a hash of these two blocks, right? But this will. Oh, sorry, you're muted.
Oh, yeah, that's a good point. So
But this will change the initial hash, so it's not really.
yeah. So the idea was if we're gonna identify a chain by the Genesis block hash, at first that seems like a pretty good idea because that should be unique for every chain. Except when a chain forks, then there's going to be two different sides of the fork that both want to say, I am the real Genesis block, or we get to keep this hash as our chain ID. We're the real one. We're the real Bitcoin.
Yeah.
Yeah, that's interesting. So
you need some kind of fork ID along with.
Yeah, right. So then the most natural extension of the idea is that then you include like the Genesis block and the first block after the fork on your side of the fork. Except that, yeah, but the problem then I guess is like, there's always going to be at least one side that says, no way, I'm not changing. We just have one blockchain. Your fork is just like every other orphan block. Yeah. Yeah, that's an interesting.
The main purpose of this is for interoperation, right? So you wouldn't address a chain that you didn't want to interoperate with.
Yeah, but so I mean, Jim, imagine here you are using Bitcoin in like summer of 2017, and you're using the chain that has the proper Genesis block hash. Now there's a fork, and now there's Bitcoin and Bitcoin Cash, and they both say we're the real Bitcoin. We're the chain that uses this particular ID. How do you like make it clear which chain you're trying to interact with?
Well, if you know what the fork was, then you've identified which chain.
Yeah, they're just chit-chatting right now. Go ahead.
Well, I guess the problem is like, let's say I'm on the Bitcoin Cash side. I think that's the real, maybe I don't even say that's the real Bitcoin, but that's the one I want to use. So I make my transaction, maybe I'm going to send Tomislav 1 Bitcoin Cash. I make my transaction, I sign it, I send it to a Bitcoin Cash node. Someone who's a Bitcoin user hears it and starts passing it around the Bitcoin network. Now I've transferred not only the Bitcoin Cash that I intended to transfer, but also because it was replayed, I've transferred the Bitcoin that I didn't mean to transfer. So like whenever there's a fork, it really is like a breakup. Like there's a fight now. Who gets to keep the chain ID?
But there is also, you will have different validators, right? So if you have the same identifier, or like a Genesis hash, you will definitely interact with different groups, right? It's the same identifier, but you will definitely know this is two different networks. But I'm just thinking that can they both have the same identifier?
Well, the whole reason we wanted different identifiers in the first place was for replay attacks, so that my transaction on one chain doesn't get also executed on a different chain.
Yeah, but I'm thinking that we have two different validators, so you will not, you cannot be confused.
Yeah, I can't be confused.
Is this possible?
But in the scenario where I'm trying to pay you 1 Bitcoin Cash, you're really incentivized to gossip that transaction over to the other network, so you can also get 1 Bitcoin.
So you're saying you already deploy on one network?
Yeah.
But no one will accept this deploy on the. Oh, you will create a different deploy, right, on the second network, which is also valid on the second network, but somehow
Yeah, well,
uses the
it's the same
same.
deploy, really. It's the same bits. Like, it has to be the same bits, because otherwise you'd have to forge my signature, right? The best you can do is use the exact same transaction that I've already created and signed.
But you don't have a parent hash, correct?
The transaction never has a parent hash. Only a block has a parent hash.
So right now, I can watch the transactions on Bitcoin Cash and replay them on Bitcoin.
No, they solved it because one or both of them changed their chain ID. I think Bitcoin Cash sort of like caved and changed their chain ID.
Okay, so if we have a chain ID, what's the problem?
Well, that's exactly the problem. We're trying to come up with a nice objective way of determining chain IDs. Because like everybody wants to be chain one, right? I don't want you. No, you're not chain one. I'm chain one. You can be chain two. I want the good ID.
So maybe this is like a regular situation, you know. Both networks are trying to build the longest chain, and one will fail, right? So the other must change the network ID.
Oh, that's right. Yeah, whichever one is not able to build the longest chain is the one that has to. That's exactly. Honestly, that's exactly what it is, right? When you're walking straight at a bigger guy, you're the one that better move.
Yeah.
Yeah, that's a good point. Yeah. Cool.
So, I mean, when you have a fork, okay, so you have the chain ID, the original chain ID, and then you have forks. And you have these block okay, each fork has the same Genesis block, but it has different fork blocks.
Yeah.
You know, which a fork here, and then a fork later on, and a fork, some list of forks. So if you were to hash this whole list of forks with the Genesis block, you would come up with an ID.
Right. Yeah. Yeah, so that seems right. I agree that would do it. But the problem is, like, are people actually incentivized to comply with that? So, like, let's say, we've started off and we've got the same Genesis block, and now later there's contention and we want to fork. And so it's like, yeah, we agreed a long time ago that whenever we're going to fork, we're going to do it this way, and we're each going to, concatenate the new fork block and everything, and those will be our new chain IDs. Like, this was the protocol for a peaceful breakup. And then, someone comes along, maybe Steve comes along, and he's like, screw you guys, I'm not doing that. I'm keeping the original chain ID. That's the tricky situation. But how about this idea? Every time the consensus rules change, whether it's contentious and it's going to split or not, maybe it's just a bug fix or a relatively widely accepted improvement. Whenever the consensus rules switch, then you switch your or I don't know, is it better to switch or like append or concatenate the new block's hash?
How can you detect this kind of situation? You probably want some kind of automatic change, right? Integrated in the protocol.
Yeah.
But how can we know that fork is happened?
Well,
because in a sense, this part of the DAG will be like an orphan, but we have like a special situation where we are saying it is not orphan, it is new network.
Yeah.
Right.
That's right. Yeah, I think, so here's how okay, that's a good question. I got my head stuck in substrate world for a second, but in substrate world, the entire runtime logic is stored on chain. So you can tell if you do that, that's not trivial. Like that's a lot of on-chain storage sometimes. But if you are willing to do that, then you can identify it pretty easily, because you can say like, it's basically compiled down to a WASM blob, right? But so you just have some long hex, like some binary blob that represents your runtime. So you say like, okay, this block has different runtime than its parent block, and the parent block is always explicitly mentioned. So therefore it needs a new chain ID or something like that. So like part of, oh yeah, so maybe like part of block production is check whether the runtime logic has changed, and if it has, update your chain ID accordingly in this deterministic way that Jim just described.
Hmm. So
yeah.
Oh.
Yeah, no, go ahead.
So so if you are on the chain that didn't change, you can just continue with the same identifier.
Yeah, that seems like probably an objective way to do it. Yeah. Only when you're the one that wants the bigger blocks or whatever, then you have to change your chain ID. Yeah. And actually, like in that, I mean, this is a pretty like kind of a case study, but I feel like that would have made everybody happy in Bitcoin, because the Bitcoin Cash people would have had to change their ID for bigger blocks, and the Bitcoin Core people would have had to change their ID for SegWit, and then nobody is the original Bitcoin.
Yeah, and you will definitely know.
The standard going forward for decentralized identifiers, the DID standard, would seem to me to be what to follow for any decentralized identifier. And if we use that standard, then we're all talking the same language.
How this is standardized?
The DID standard, or what?
Yeah.
How is it what?
How is standardized? What does it mean to have the decentralized ID?
Well, you have to, no, it's a federated network. So your directory becomes part of the federation. And it's actually first come, first serve on self-sovereign identities. So you create an identity and then you own it, so to speak.
And so you're saying we could do a similar thing like with the chain IDs?
Yeah, I'm saying, just federate on the decentralized DID network.
Yeah. So Jim, does that kind of serve as like a registry of IDs?
Yeah.
Like a directory or something?
It's sort of, it's the new DNS.
Oh, cool. Oh yeah, and DNS is really just like the new phone book kind of, right?
Yeah.
All right, cool.
But I'm thinking that Joshy, you just presented this idea that ID is closely connected to the hash of some data.
Yeah.
So for me, this looks like a generalization of this federated ID, right? Because if you can just made up some name and say, okay, I have this name.
Yeah.
I don't see a way to communicate this name and to agree that this is your name, because I can say the same thing. So in that sense, you must have some kind of connection to the data, or some hash or private key.
Yeah. Right. So you're saying hashing kind of solves that, because like we don't have to communicate the name, we communicate the actual data, in this case the genesis block, and then you can from that calculate the name and make sure it's the one you wanted.
Yeah, yeah. So you cannot forge it or something.
Yeah, right. Yeah, that seems right. And that's like even kind of the big thing that IPFS is doing, right? With like content addresses, or what do they call that again?
I
Content.
don't have.
Are you familiar with IPFS?
Yeah, but I don't know details. So
Oh yeah, yeah, cool. Well, the only part that I was talking about there is that like instead of giving a name to a file, you know, it's not like slash documents slash Joshy slash whatever. It's identified by its hash.
oh yeah, this makes sense. Yeah.
Yeah. Well, that was kind of cool. I feel like we're onto something there. That might be a sufficiently. Oh, how does it work with a DAG though? I'm thinking of it as a chain the whole time. So I guess there's generally still one Genesis block in a DAG. And then, oh yeah, how do consensus rules change in a DAG? That's kind of an interesting question. Because like with a blockchain like Bitcoin or Ethereum, you've always got this point where you can say like, okay, after such and such block, the rules are going to be different. You know, like we're adding this feature or we're changing the block size or we're doing the DAO fork or whatever. But in a DAG, I guess there's still a notion of block height. But it just seemed for a second, it seemed harder because you can't say like, after this one particular block, like this is the last one with the old rules, and then the next one will have the new rules. But in a DAG, there's all this other stuff going on concurrently.
Hmm. Can we pick only one, or I'm thinking just like a simple repository, a Git repository, right?
Yeah.
You can always find the parent, one parent that is
Oh, like the common ancestor?
common ancestor. Yeah. Is this similar case, right?
Well, maybe. Yeah, I mean, I guess any two blocks in a DAG always have a common ancestor. In the worst case, it's the Genesis block.
Yeah.
In the best case, it's, you know, right there, they're direct siblings. So I guess the question is like, let's say we've got this this DAG-based cryptocurrency, and we decide like we want to change the consensus rules at some point, like I don't know, add more decimal places of precision, or like mint some new tokens, or burn some, or you know, I don't know, whatever. How do you do that in the DAG then? What's the decree? Instead of like after block 10,000 the rules change to this, how do you do that?
Yeah, this is an interesting question.
I wonder if it's enough. I wonder if it's enough to still announce a block height and just realize that like that will happen at not exactly the same time for everyone. Or what do I even mean by for everyone? Like for every transaction, or for every block or something?
Or maybe after some block height, there must be some special sequence of blocks that are like a synchronization or something. But I'm not sure that this solves anything.
Yeah. Oh, that's an idea. So you're saying like maybe make some kind of coordinated effort to have like the DAG kind of collapse back down to a pretty skinny thing, and then do the switch, and then it can get as
yeah, exactly.
Oh, that's a cool idea. And yeah, right. Yeah, I guess in theory, like you always should be able to compress it back down pretty quickly, right? So like if suddenly everybody just stopped making transactions, then you just can say like, okay,
yeah,
these 90% of blocks are all mergeable. Here we go. This is the official state of the chain.
This is definitely slow down. And
yeah, that's right. You have to throttle
multiple tracks on one. Yeah. From our chain to Ethereum, right?
Yeah, that's right. And then back. Yeah. Yeah. Well, it might not, in practice, that might work pretty good because you could say like, look, there's some of us who are interested in making this change. If you're interested, just here's when we're going to throttle it back, make sure your transactions are done a healthy amount of time before then. If you're still going, submitting stuff, that's fine, but you're probably going to get orphaned off. Just be aware of that.
Oh, yeah. Yeah, the main chain will do as before, right?
Yeah.
Only the split will have this starting position.
Yeah, and it really almost is like in some ways like a new Genesis block.
Yeah. Oh, yeah. So we need to find like our Genesis block for the second network, for the fourth.
Exactly.
Right?
Genesis 2 or 3.
Yeah.
Yeah. Oh, wow. And then there really is like so then if you take this view of the DAG and you like zoom way out after we've done a whole bunch of those things, you can find like almost this blockchain embedded in it where the blocks are just these like consensus change blocks, like here's the real original Genesis block. And then here's where we changed consensus the first time and it got real skinny. And then here's where the next one was. And there's all this concurrency in between.
Yeah. Nice.
Yeah, that's it. We need to definitely draw some diagrams for that.
Yeah.
Or a blog post or something.
Yeah, these other Genesis blocks are really, it makes sense to call them like a Genesis because they are really like combining this DAG to only one block.
Yeah, and it's totally like there really is a totally unambiguous like first block of Bitcoin Cash or first block of Ethereum Classic or whatever.
So the hash of this block can be really a network ID, right?
Yeah, I really think it can be. We just had to generalize it a little bit.
Yeah, you don't need the hash of previous Genesis. You know it, right?
That's a good question. Oh yeah, do we even need the previous Genesis at all? Well, okay. If I go only with the new one, the post fork. Oh yeah, that's totally fine because like if you want to know, well, for one thing, maybe you don't even care if anything came first, but if you want to know whether anything came first, there's always just go to that block and there's always a parent pointer.
Yeah.
And so follow that one step of parent pointer. Now you've got the new, or not new, like the previous ID.
Yeah. So the hash of Genesis really, it's not a problem for, as you said.
Yeah, that's right. It's not a problem. And then there's like, we almost need this new vocab to distinguish. There's like these kinds of Genesis blocks that we've been talking about that includes the fork blocks, but then there's also those super special ones that don't have a parent pointer.
Oh yeah. Oh, nice.
Wow, actually, okay, so let's say we're like tracing back up this blockchain. This in our lifetime, I don't know if this will happen, but eventually people will be born and these blockchains will have already existed long before and everything, and they might want to do some like ancestry or something and say like, okay, well, this is the blockchain I know, let me trace it through all these previous consensus changes and everything. And at some point they get to a block where it says, the parent pointer is blank, and they're like, dude, I can't find that block. Like, you don't really know whether that's one of these like special Genesis blocks or whether you just happen to like no historians have kept that data around long enough for you to look at it. I mean, I guess like you could make some argument of like, well, this parent pointer is 0x0, so that was probably a real Genesis block, but like, I don't know, something might actually hash to that we just don't know of yet.
Yeah. Oh, you just made up some this hash.
Yeah, well, yeah.
You didn't know about this hash.
Yeah, maybe we're going to start a Genesis block or a blockchain and we choose our Genesis block. And then we're like, hey, what do you guys think about giving it a parent pointer, even though there isn't really any block? And everybody's like, yeah, that sounds good. That'll kind of like fuck with the future. Yeah, I guess there really wouldn't be any way to know.
Yeah. Oh, nice cup you had.
Oh, thanks. Yeah. My fiance.
Yeah, I noticed before. Yeah, cool.
Yeah. So have you done any rholang recently?
Well, I didn't. Yeah.
Yeah, I haven't done that much rolling either. I was kind of kicking around the idea of multi. I don't. Well, I was kicking around the idea of multi-sigs, and then I was trying to think about two things. One, like what's the best way to implement that in Rolang, and then two, what's the right thing to call it? Since like inside the Rolang world, it's not really signatures anymore. It's like, you know, I have the name of this channel. It's like an object capability kind of thing. Like I have this channel, multi, like, I don't know, multi-authorization or multi-object or something.
The simplest thing is, you know, that you have that you receive the pattern of the capabilities in parallel. That's trivial.
Yeah, well, so like let's say it's a you know, Jim, you and I have like some shared Rev wallet or something, and the rules are like neither one of us can unilaterally spend it, but if we both agree on it, then that's good. Then it goes through, right? So like the two parts are we have to specify what the transaction itself is, like who are we trying to send the rev to and how much. And then the second part is we have to make it clear that we've both approved. So like I was trying to wrap my head around what that might look like.
Well, you know, the object pattern that I've been working with is that you simply have a proxy object that you wrap around the wallet.
Mm-hmm.
Okay, and so you receive a message, which is the required capabilities in order to access the wallet, followed by what gets sent, what you want to do with the wallet.
Right.
And then you know, only the contract needs to know when you create it. Only the proxy object needs to know the actual wallet capability.
Right. So like the underlying wallet has some capability itself, and that thing, like neither one of us actually knows that ourselves. It's encapsulated in this thing that we're going to send our messages to, and then it will forward them appropriately. That's what you're saying? Yeah, that sounds right to me. So then the trick is like inside that proxy, when it's just a forwarder, I think you have that built already, right? But the harder part though is like, let's say I make this proposal, like, you know, from our shared wallet, I want to donate 1 rev to whatever charitable cause, and it shouldn't go until you approve it. So I was thinking about what that logic might look like.
Well, you have to pass him a capability to make that transaction. Okay, and you have to.
Joshy, can I ask?
Okay, you know. Yeah, I guess I have to think about it some more.
Yeah.
I thought it was easy.
I thought it was easy too. I was trying to code it up in the 15 minutes before Chris showed up last week, and I realized it was harder than I thought.
Yeah, well, originally I was thinking you just have a state in the envelope.
Yeah.
Of the transaction. So you create a transaction, and the transaction has a set of n unforgeable names.
Yeah.
And the code gets executed
And what is the like a simplified situation if you have only one person to access a wallet, for example, so you send, for example, some secret token or unforgeable name to the contract, and the contract says, okay, I know this unforgeable name, I give it to someone, and now I receiving it back, and this means that you are allowed to do this operation. So can we just apply this multiple times and say I will do this if I receive two of these forgeable names. So like I'm thinking just in the same way, but you know, two pieces of forgeable names, not one, but two.
Yeah.
Is too simplified or?
So maybe not. Let's think about the one user scenario again. So I want to make sure I understood that design correctly. So like there's some underlying capability, like Dan would call it the superpower. And then there's the like intermediate, it's like this multi-sig where 1 out of 1 people have to sign. Mm-hmm. And then there's a human or what, maybe there's more abstraction up the chain, but like for our cases, that's the user is next.
Yeah.
And so you're saying when the wallet, or not the wallet, when the forwarder got created, it sent an unforgeable name out to, in this case, all 1 of the person who's supposed to be allowed to use it. And then when messages come back to it, the messages are like tuples of this auth key that was sent out to the person and whatever the real thing is that should be forwarded. Yeah, that seems like a good design. That's actually maybe a really good way to start, because that's different than the one-person forwarder that I had in mind. Not by that much, though. So, oh yeah, go ahead.
Is it true that this unforgeable name is really this object that has this capability, or am I wrong? Because I see this as a token, like you are allowed to do something when you send it back.
Yeah, I think that's a totally valid design. Yeah, I think that's totally right. I just, it's not the only design, and it hadn't occurred to me before. So I think it might be the key. So the subtle difference in the way I was conceiving it was when the forwarder is created, it sends this, it makes some new unforgeable name, sends it to the user, which I think so far were the same. But then the difference is I was thinking that the user then sends some message on the unforgeable name that it was given. And so messages that come in on that name are known to be good.
But I think that's too different, right?
What's that?
This is not too different.
It's not that different. Yeah. The difference is, when in my scenario, only the user even knows how to contact the forwarder in the first place. Whereas in your scenario, actually, how does the user even know where to contact the forwarder? There's just some like well-known channel or something, I guess.
Yeah. I didn't think about that. Yeah.
This is part of what I've been contemplating. Dan brought up, when you're given a capability, how do you determine what that capability is?
Yeah, Chris was talking about that yesterday too, or last week too. Like if I send you some unforgeable name, you don't know whether it's a wallet or a vault or a ballot or a kitty or whatever.
I mean, this is fine, right? You don't want to reveal anything about this token, this unforgeable name, right?
Oh yeah, so you're saying like, if I'm sending you something, you're just going to assume it's junk unless we've already talked off chain and you know to expect something?
Yeah, because maybe now I can give you some authentication token for my Google account. But
yeah,
I don't want to give all this information inside the token, right? To say, it's for my account, so you can just connect them.
Yeah.
But
yeah, you can send both of these unforgeable name and also another unforgeable name as a return channel to the forward.
Yeah, right.
But if they can't,
I'm just
if they can't forge it, I don't see how. If it can't be forged, you're not really giving anything up. But I don't think it's a solution to agree off chain what it is. About as far as I got with the idea was that, I can tell you I'm sending you one thing, but I send you something else.
Oh,
Okay.
yeah, right.
Okay, so what we need is a way um, of identifying the identifying something that I'm being sent.
Mm-hmm.
And
You mean off-chain or
on-chain. Okay, and in general, we can't do that. But we can we can use a certain pattern where we send them a contract along with code. We send them a contract address along with code, along with the message that we're going to send, that we're going to allow you to send to it. Okay, we send you a capability. Wait. No, the capability is the contract. And if it's a public contract, you can look it up, you can verify. This is a wallet contract. Okay. You expected a wallet contract, and indeed, the permission they're giving you to run something on their behalf, so to speak, is what you expect. You can match the pattern of that message.
Jim? I'm not sure that I understand everything. You said on-chain identifier. What exactly do you mean? On-chain identifier. Why is this a problem? I'm not sure that I understand this part. I mean, we have an unforgeable name. You can just say send someone to a forgeable name, and this is like a unique identifier. And
right, but you have no way of knowing what that capability is, or what's
but when you send this unforgeable mail to someone, this someone will know, right?
They'll know that they got something, but they won't know what they got.
Right.
But they created this unforgeable name. So if I create this unforgeable name, I will add to it. I will remember that this unforgeable name gives you these capabilities, right? So when you send me this unforgeable name back, I will know what you
yeah,
can.
but I'm talking about when you're receiving a capability, not
Right.
some kind of capability you already had. Okay, you're receiving a capability from me, and now you're going to do something with that capability. But that capability, if you send to it unforgeable names that I don't have, I could do bad things.
Wait, what kind of bad things what was that? Last part?
Well, let's suppose he's going to pass his wallet address to that, send his wallet address to that unforgeable name in order to do like a multi-sig wallet, as an example. Okay, so he has to give his purse to this contract as well, to his name, as well as it has a capability to transfer money to you as long as you transfer money to me, right? If it either does both transfers, or it doesn't do anything. That's a use case. Okay, the general problem is, how do I know what capability you sent me so that I can trust it to send my private information to it? I have to know what contract it's going to run.
Yeah, sure.
Okay.
Yeah, but you can see it. You can see it in the contract that in this contract that generated this forgeable name.
You don't know what
I mean,
contract. Generally, you don't know what contract generated the unforgeable name. It's just a name I give you. I did a new XYZ, and I sent you XYZ. And
yeah, but you must have some point where you can when you can send your unforgeable name as object capability that will do the work. But this endpoint should also give you a way to ask, you know,
exactly.
what this
And
forgeable name is.
Yeah, and
Is it
well,
valid?
and
What permissions?
it has to be something I can't lie about, right?
Exactly. Because you will see the contract that created this unforgeable name. So
Where,
that you,
how, if I send you an unforgeable name XYZ, how do you know what contract created it?
but if you don't show me, if you don't show me the code, and if I cannot compile your code and check for all the behavioral that I can trust, I will not trust you. You must show me the code that generated this unforgeable name, this object.
Well, I could show you the wrong code.
Oh no, it's
yeah,
on.
and this is enough.
It's on chain though. Yeah.
Yeah, it's on chain, so I can check all this stuff.
Created it is on the
Yeah.
blockchain.
And it must be, because other way you don't know, because now Google can give you a authentication token, but you must trust Google that you have these scopes that these permissions that you think you have.
Yeah.
And in case of Google, you cannot ask is what permissions this token gives me. You just have to.
Right. Okay. But so Tomislav, this is the piece I was missing that I think I have now. So like, I've gotten some new unforgeable name in my inbox. You know, I suspect that it represents some kind of capability, but I didn't ask for it. It was some kind of like airdrop. So now I'm wondering like, what the heck is this thing? So the solution that I didn't see before is I can see what deploy that unforgeable name was created in by looking back at the blockchain. And then I can see, without even having to trust the deployer who might be incentivized to lie to me, I can see what code is actually there with consensus reached on it and know exactly what this thing is.
Yeah. I don't see other solution. I mean, I see blockchain exactly for this.
Yeah, I guess my problem is, I don't know how, to write a piece of rholang that does that.
Yeah, well, it would have to be off-chain, actually, because I don't think rholang can look back at the history
Right.
of its chain.
So what I'm talking about is a programming pattern.
Oh, I'm not talking about history.
That lets us do verified information on-chain, okay, directly.
Oh, but why would you want to do it on-chain? Because then you just have to pay for all that computation on. Like, you don't need to convince the whole world of what it does. You just want to convince yourself of what it does.
That's right, and that's what this pattern does, okay? And the pattern includes the proxy, okay?
Oh, you've solved this already?
Well, I haven't worked through all the details, but
Yeah, right.
I've been
This is the idea.
and introduced the idea. Because I need it.
Yeah.
I need it for the community stuff that I'm working on. The solution that I have so far is that that you have a sort of a higher level capability pattern. And this higher level capability pattern has the unforgeable name of the contract that the capability is associated with. And the message pattern of the capability you're giving to send to that contract. Now that still doesn't answer the question. No, if I'm saying, if I'm giving the capability to a contract that will transfer my money to you if your money transfers to me, pretty simple, method in the contract. So I just need a
So if we have a one contract, you're saying you want to have one contract that exchange two transactions atomically, right? So I'm imagining
that's not too hard. Okay, that's a case where the message received by the contract is maybe transact and then A par B, where those are the two capabilities, right? It's so when both capabilities are provided, okay, it will try anyway to complete the transaction.
Yeah.
And it sort of has to do some more verification along the way. Like I said, I haven't thought it through completely, but basically, when it receives both purses and well, yeah, like I said, I have to think it through completely. But basic idea is that it creates the capability of each person to collect, and if those capabilities are proven, so to speak, then it completes the transaction and returns those capabilities to each of the participants, whatever. But
so in a sense, we have two different operations, right? So one operation is making transactions from one account to another, right? And we need another operation. So this first operation that is making transaction, if this operation can create an forgeable name that has capability of making transaction of this amount, and so and then we send this capability to this other operation, which is capable of executing this transaction, but in a way that accepting another capability of this first operation, of this just transaction.
Yeah.
So this second operation can wait and do this atomically, right? Because you have two different transactions, two different capabilities from two different accounts that will execute in the same
Right.
way.
So let's say we're trading, 100 rocks or revs for well, I'll just use Ethereum for now. 100 rocks for an ETH. Okay, so you provide a purse to this contract, which does an atomic exchange, of 1E. And I provide a capability to contract that's 1 rock. Okay, so if it, this thing matches the pattern of 1 rock for 1E, okay, that we can check and or be certain of, then then the contract uh, can do the exchange when it receives both capabilities.
Yeah, this makes sense. And probably you should have a way to revoke your capability, right? If you know this other party, you must be sure that you can just cancel this.
I mean, you can have a transaction on this transaction wrapper. You can have a transact capability. You can have a revoke capability, right?
Yeah. So I'm thinking that is it enough to just have unforgeable name as a token of like a proof of this object capability?
Yeah, one pattern I discussed last week was like whenever you send someone a thing, a capability, it should be like, instead of just being a simple, pure, unforgettable name, it could be like a two-tuple where the first tuple is like a unique identifier that, or I guess it would have to be a bundle of these things, where the first one like identifies what contract it came from, you know, the rock, mint, or whatever, and then the second one is unique to you.
Yeah.
So then you could identify what it is by pattern match. Oh, but you can't pattern match on the bundle. Oh, that's tricky. Oh, or can you?
But you can send a regular tuple, right? It doesn't have to be a bundle.
Well, the only problem is if I send you, if you like you receive this regular tuple, and it the first thing is like tells you a contract ID and the second one's unique to you. If it's unbundled, then you can destructure it and then send a fraudulent tuple to someone else. You know, it would seem authentic because you had packaged up.
Yeah, you can do it, but the receiver can easily check. He will ask.
Yeah, check by the same techniques you were describing earlier.
Yeah.
Right. But so if we're relying on checking by those techniques anyway, then what value did we gain by making it a tuple?
Oh, I was thinking that you want to have like an identifier where is the contract that will respond to this capability.
Yeah. I mean,
I'm not sure.
The pattern I'm suggesting is that you provide the okay, well, I guess I see the problem with that. In order to verify the contract address, it has to be in the registry, and we don't want to put every person in the registry.
Yeah, if we just have an unforgeable name, right, we cannot locate the contract. Yeah, we must go to the registry. Yeah.
No, but if there's a trusted contract that we can exchange capabilities with respect to, we know what that contract does right away. I mean, you know, it's.
You mean you know this contract because you have this registry name of this contract, right?
Yeah. Well, I guess with the new, now with the name things, we can change what's in the contract, which I guess muddies the water a little bit. But assuming that we can, can use well-known contracts
Well known, you mean registered in the registry, right?
Uh, and essentially have a proxy which really says, I'm giving you the capability to run this code on my behalf.
Yeah, yeah.
To get the capability, so to speak.
Yeah.
Um, and so I know what the capability is going to do.
Yeah, yeah. You can ask for capability, right? I'm thinking in the same way as now, how now is working single sign-on on Google or Facebook or similar. You ask for scopes, for permissions. You create a request for a token, and you say, I want permission to user's email, date of birth, or whatever. And you always get the same characters. You always get the same token, but this token have different capabilities behind it. You don't know it just by looking at the token. You must ask the authority who give you the token.
Yeah, that's an interesting pattern I hadn't thought of too. That I mean, it almost is reminding me a little bit of like a revoke or attenuating forwarder, where like if I have, maybe I have all these capabilities, and then you want to, I want to give you an access token that has like, so that I can delegate some of these capabilities to you without also delegating the super sensitive ones. Then like you're going to send messages to this forwarder, and only some of them are actually going to get forwarded. And if you try to send messages that do things you don't have, that I haven't delegated, then those ones get discarded. But the ones that I did delegate, those ones get forwarded.
Yeah. Yeah, I'm imagining this contract should create new name and store it internally, right? And for each name, it will store different permissions or something that is related to execution. And then when you receive this unforgeable name later, you can say, okay, it's my list. I created it, and these are the permissions that I can do. And
I was thinking of like, you will give a read capability on on let's say a well-known purse contract. They have the ability to read capability on a well-known purse contract. And given that, well, for example, you can determine what the purse contains, what's in the purse. Okay. And you can give a capability to read a purse well, okay, in other words, you can both say, this is what we're going to, you can both say, this is our agreement. This is what we're going to trade. And this we can verify because it's a well-known URI for the first contract. Or we both know it anyway.
Mm.
Doesn't necessarily have to be a registered name. This has to be the name of a contract we both know. And we know what it does. If I say I have 100 rocks in there, and mine, you say you have an eighth in yours, we know that we know that this person is correct. Okay, and we can also have a capability in this first, so that within the contract, the transaction contract, when we receive an update capability to each of them, which we don't share with the two parties, to verify that that update capability goes with the read capabilities that were exchanged. So we create this transaction wrapper. I give read capability to my asset. You give read capability to your asset. And well, give a read capability and a write capability. The contract keeps it, it's not shared. Okay, but I can get a read capability.
Hey guys, I gotta jump out.
Okay, then I think it needs to be. I think if we
Nice to see you, Joshy.
if we
Yeah.
don't know contract, yep.
See you guys.
See you. So I'm not sure that I understand you. What exactly do you want to do with these read capabilities or write? I mean, you're talking about like a specific case, right?
I'm talking about an atomic transfer of assets.
Okay.
The use case that I'm using, which is not that different from the multi-sig case, really.
But maybe you don't want to give maybe you don't want to give this complete read permission or write. I'm thinking more like I want to give permission to this contract to do only this one thing, right? I don't want to give this permission to you. I want to give this permission to this contract that can atomically make transaction. And I will send my permission, my object capability for this one transfer to this contract, and I will ask you to do the same thing, right? And we know the code in this contract, and we can say we trust this contract. And when I send my capability and you say send your capability, in that moment, who will be the last transaction will occur.
Yeah.
Right.
Well,
But
the issue I was dealing with is I can send you the capability, okay, to access my wallet contract, and I can give a message pattern that's transfer.
You mean you send to me or
to the contract?
Okay.
To the transaction wrapper, right?
Okay. Yeah. Exactly.
The capability to transfer 100 rocks to you. Okay, that I can do that pattern can be matched in the contract to make sure that that capability is in fact to transfer 100 rocks. Okay.
Yeah.
Now, I may not have 100 rocks to give you, right?
Yeah.
That's
That's okay.
Up with the read capability, where you could.
Yeah, but this is completely okay because both of us we are giving capability of this on this one transaction, right? And if in this moment this transaction is not possible to complete, this transaction contract, this transaction wrapper, it can be implemented that it just forget for this object capability and report error, and it can just say, okay, if you want to make this transaction, do it again, right? Create new permissions and send it back. So I don't see the problem, I'm just thinking that
you won't get a consensus on the transaction, and
yeah, You have a point where you know what happened. Yeah.
Well, that's a whole nother issue, which we can't get into this morning. You know, how do we know if a buck gets orphaned? You know, it's a tough thing.
Yeah, but Kelly show us how can we do this, right? We can just get all the hatches in the deck and just find the finalist
and see if it works. Yep, it's a little bit gets a little bit complicated. I mean, I still want to try the case of the get ticket contract, which gets ticket 1, 2, 3, 4. I want to try that on testnet from 2 different nodes where we both get ticket number 1 at the same time and see what happens.
Did you try it?
Yeah, I haven't tried it yet, but I was going to try it this morning. I didn't get around to it.
That is interesting case.
Well, I guess I can try it on 2 different nodes myself, right? We've just deployed to 2 separate nodes.
Yeah, exactly. One will be orphaned, right?
I deployed the contract. I have to wait till it gets added to a block, added to the chain, and then we both do a get ticket at the same time. Or I can just run 2 at the same time, whatever.
Yeah. Only one will win, right?
Right.
So in that sense, we should find our deploy ID somewhere in the childs of last finalized block, last finalized hash.
Yeah,
I'm thinking like that.
Crispy seemed to suggest that wasn't a problem. I want to prove to him that that's a problem. Because how do I know that my ticket 1 is no good and retry to get another ticket number?
Yeah, this is the other question, right? The first question is how do you know that it's finalized? And you can definitely know, but yeah, the other way around is also the valid question. Is my deploy orphaned? Can I be sure that it's orphaned? Right.
Right. Big problem. Needs to be solved. I mean, generally we avoid requiring anything to be so sequential, but
no. I'm thinking that we can be sure, right? Because maybe not in the same moment when we are sure about a finalized block, but we can definitely know this block will never go into the deck. You know, because it becomes too. Majority will conclude that this block is not a part of the valid deck, because validators must confirm with majority. So we have like a.
The question is, how can I determine that from my app?
Yeah, this is another question. So I'm thinking that if we can. If we collect all the hashes in the deck, and we know what is the finalized one, we can calculate which part of the deck is like. Well, I'm not sure of that, but I'm thinking that I'm not sure that is this enough information to conclude this, but yeah. Maybe with the help of fault tolerance, we can conclude this. Yeah. definitely not easy question.
Yeah.
I wanted to ask you, do you have a little bit of time to maybe talk something, something about this Susskind presentation of relation with quantum mechanics and general relativity?
So,
I-
can I talk you into allocating some number of hours per week for
for this kind of stuff? Yeah, that would be nice.
organization?
Sorry?
Can I talk you into committing some number of hours per week towards doing fulfilling some role in the Art Chain member organization?
Well, I'm definitely for that, and I can give some of my time. And also, I was thinking that maybe I can talk about this editor plugins that I built for rholang, because
Well, there's a number of areas where I think you could contribute well. One is the Art Chain improvement process. I think that would be a good one for you to participate in because you have some good improvements that we want to get into Art Chain.
Sure.
So, Kelly will be a guide in the process. It's just like the Ethereum process. So,
okay, I'm not familiar with the Ethereum process, so yeah.
EIPs.
Yeah.
Ethereum EPIs, EIPs, you know what they are, right? The Ethereum
No.
EIPs?
No, I'm not.
Or
Sorry.
okay. EIPs generate the ERCs.
Okay.
Okay, so basically it's like a two-stage thing. An EIP is entered. I mean, it doesn't have to be a two-stage thing, but it basically, it's part of the governance of Ethereum.
I see.
Okay, in order for a change to get implemented, it goes through the EIP program.
Oh, I see.
Okay, so clearly you would have to know what it was to commit some time to that.
Oh, definitely.
But, we have Kelly devoting some time, you developing some time. And, other people have committed time, but they haven't specified what they committed the time for. So we can reach out to these people to get people to help with the EIP program. Okay, another area where you can really help is with the DApp Developers Working Group.
Yeah.
You
I was
can be
thinking on that, yeah.
Okay, there. I don't think you would want to get involved in administration of it at all, but you could be a guide.
Rather not, yeah. For support for dApps, yeah, I'm definitely for that. And also, these editor tools are very closely related to that, right? Because if you are developing dApps on Archain, you will definitely you need to use some editor and help from editor.
Yeah, and definitely that would be a good thing for the any of the work studies really, but certainly if you can come to a DApp developer meeting or you would have a good audience to show editor stuff or whatever.
Sure.
That's what you could do, and that would be appreciated.
Sure. I can. Yep.
You know, and if you could guide any of the collab work studies, that would be help.
What exactly do you mean on this part?
Well, I'm sorry?
What exactly do you mean on this part? Work studies.
Guiding the work study?
Yeah.
Well, you know, one of the main problems that we have in the work studies is that everybody's JavaScript isn't that good. Their command line isn't that good, although I can guide on the command line pretty well. Although our GitHub is lousy. We always screw up with GitHub. You know, Node.js knowledge, etc.
See, I can definitely help in this area.
Okay, well,
I cannot commit until August really. Now it's Saturday. I'm going to Poland to Haskell's summer school, and also I have vacation in July, so probably with the beginning of August.
It would probably be good if you could commit to guide one work study a week, or even one a month. Any commitment is valuable, and would really, help the rest of us idiots to get moved along in our efforts in robot and community and all these other things.
I see.
So the 4 p.m. New York time, Monday and Thursday sessions are open. So you could choose to be a guide on that one. Now Tuesday at 4 p.m. is the DApp Developers Group, which is not really a work study.
Oh, I see. I see in the calendar. Okay. This is pretty late for me, but okay.
Well, we can always move a work study. The problem is having a work study without a guide.
I see.
In fact, 2 p.m. on Tuesday and Thursday, we used to have work studies, but because of low attendance, we don't list them, but we still have them if there's something to talk about or something to do. So 2 p.m. Monday, Tuesday, and Thursday is a potential hour. And really, you're the guide. So you pick the hour. Right?
Okay.
So if you wanted to have
sure.
10 a.m. on Tuesday, that would be fine.
Yeah, I'm thinking maybe like in this time, like today, right? After rolling hours.
Today is bad.
Okay. You mean Thursday? Thursday is bad. This is what you mean.
Thursday. After rolling hours. So would you just start at 12 p.m.? Schedule a work study?
12 p.m. Topic.
Is an hour long enough for the rholang hour?
Yeah. I don't know. Yeah.
I mean, we can make it New York time.
Okay,
Yeah,
we don't have to decide right now, right? We can schedule something later.
right. But you know,
Yeah. Okay. Now I know. Now I know what you're asking me. So.
yeah. No, I was hoping
Uh,
to get you as a coach for one of the sessions next week.
So next week I'm in Poland, so this will be like a difficult. This will be probably difficult for me to commit to that. I can tell you when I come there, but yeah, in the beginning of the next week. But now what I'm thinking is what exactly. Yeah, but maybe we can discuss this on the first meeting, and yeah, I can find out what is the best
Yeah.
thing to start, and yeah.
Well, you know, there's really a coach role and there's a guide role,
Mm,
and it's really figuring out what the people want to work on, sort of coming consensus of what you're going to work on. Sometimes we have a good idea, sometimes we don't. Um, if you're guiding, you certainly have a strong vote. If there's three things that we might want to work on, you could probably pick one that you
mm,
thought you could help the most with, or whatever, or is most interesting. Um,
I see. Cool.
but you know, we're working on the Archain API. Um, we're helping people with their dApps. Not many right now.
Mm. Yeah, and
But well, partially because we don't have a coach, right?
I see. Yeah, and I would like to start with GraphQL maybe. So I know you want GraphQL. So
Yes,
I discussed it with yeah.
we do have Adi anxious to learn GraphQL.
Cool.
I don't know. I don't know if you've seen the portal.
I seen something, but yeah, I'm not sure that I seen everything.
Yeah, you probably haven't seen everything, but you know, we have the beginnings of a self-sovereign stack browser-based app
Mm.
that organizes all the tools used by the community, and of course, we
Nice.
want to integrate that with the our chain wallet and all that too at some point. All with a GraphQL interface.
Cool. Yeah.
Okay, so the GitHub and our chain cache and everything is all accessed in the browser-based app using GraphQL.
Exactly. Yeah. Yeah. So then the first step is to translate all the types between protobuf and GraphQL. So yeah,
First step is to get the Archain API working again, and then
I see.
we can write the GraphQL to the resolvers to call the Archain API.
Exactly. Yeah. The first step can be that we use Archain API in the resolvers of GraphQL. Yeah. And later we can translate.
We have a couple people on board. That's the thing that's most urgent to guide, that we need a guide for. I've got one guy who is who knows JavaScript, but he doesn't know Node that well. I'm not sure how helpful he's going to be. He didn't seem, you know, I haven't seen how anxious he is to learn, and he has to learn about the protobuf calls and all that. He might be able to do some guiding for us too. And I really only want to use you if we can't get anybody else, because I don't want to use your time, right? We do offer rewards in the collab for participation. We used to, give $60 in rock for the guide in a work study.
Cool.
I don't know what it would come out to in our normal mechanism. I don't know if you're familiar with it, but
I think we can start, just without any rewards, and this is fine for me.
you're independently wealthy, huh?
Sorry?
You're independently wealthy, but partially we
no,
do it so that people get credit for their work on the blockchain, so to speak. And
Yeah.
to the areas, we collectively come up with a budget. What was the value produced in May on voting? Oh, about $1,000. And then we had 20% of the effort done by I don't know why you got 20% there. That was probably the wrong thing. You're already in here.
Maybe we can.
Okay, we don't have. The only reason you didn't get paid is because there's no Ethernet address here.
I see. I'm not sure that this is mine. Tommy.
Yeah.
Oh, you mean this is like a Tommy's lab? Okay. Yeah, but you know why I'm saying this? Before this was very complicated, so I was just opt out.
You don't have to worry about it. The only thing we need is your Ethernet address, and then you'll get paid.
Okay, I can do that.
Okay, but normally we don't bother if a person doesn't have an Ethernet address here. Now, at some point, you were put in there.
But this can also be like our task, right? To read, to make some web application that reads this document and display this more like nicer way or something.
Okay, in March, you had 563. I guess you participated in a work study.
Oh, but I didn't.
You must have. You did something. What did you do? Yeah.
I'm definitely not aware of it.
You got 20% for work study.
Mm.
Is that right? No. For rholang.
Oh.
I'm not sure how that happened, but you helped with something. Oh yeah.
Okay. Thanks.
Right. You did. You helped me. You helped solve a couple of problems I had, and so we put you in. But because we didn't get an Ethernet address for you, we didn't put in percentages for you for that month. Okay.
I will supply this my address. Yeah. Nice. Okay, I will definitely tell for the next week. Can I participate in work study? Yeah.
Yeah. Okay.
Cool. Thanks for the update. See you tomorrow, right?
Yeah, tomorrow morning. Bye-bye.